Hello friends, welcome to Mingle Tech. Now our second task is the prediction using unsupervised machine learning. Right. For that, this is basically the second task of the Spark Foundation internship. That is prediction using unsupervised machine learning. And for that, we are going to work on iris dataset as you can see here from the given iris dataset predict the optimum number of clusters and represent it visually. Basically we have to on iris dataset we have to form the optimum number of clusters and represent it visually. Yeah, for that we have to use either python or r. The dataset link is here, and for that let's move to our notebook. Now let's see. As you can see here, the prediction using clustering unsupervised machine learning. In K-means clustering algorithm, the task I have tried to predict the optimum number of clusters and represent it visually using the iris dataset. Right, as I have told you earlier. For that, our first procedure is to import the important libraries. Right. For that, I have imported import pandas as PD, import numpy as np, import matplotlib.pyplot as plt, and I have imported Seaborn and C cluster, that is k-means. For that basically we are using the clustering algorithm, that's why I have imported the k-means, and sklearn.matrix, right, and sklearn dot pre-processing mode to find it min max scalar. Right, after that I have imported the dataset. Yeah, you can get the link of the data set. I will provide you in the description, but if you want to explore it more, then you can simply go over the Google and type it irish dataset. Right, you will get, yeah, the irish dataset is there. Even you can get the link of the irish dataset from here. Either I will provide you in the description folder too. From here, either you can copy the link address and go to the notebook, and if I just showing, even simply you can press here and you can use the iris dataset. Right, even but I will provide you the link of the dataset in the description. But if you want to know about the dataset, then simply go over, simply search over the dataset, iris dataset on the Google, and after that you will redirect to the UCI machine learning repository, and you can learn from here. As you can see here, basically it has the five attributes. The first one is sepal length, sepal width, petal width, and fifth one is class. The class consists of three types. Basically, it has Iris setosa, Iris versicolor, and Iris virginica. Right. Even for whatever the dataset you are working, simply go over the Google and search it. You are either UCI machine learning repository where you can get the detailed uh, info about the dataset so that you can understand the problem and predict it more easily. Right. Now I have imported the dataset. After that, after that I have made a copy of the data. Firstly I have made the I imported the data set as iris. Right. After that I had made a copy of the data set so that I can make the changes, and even the original one remain as it is. After that I have named the column. As you can see here, there is no naming in the column, right? But when you see the attribute, it has basically the first one represent the first column represent the sepal length, second one represent the sepal width, and third one is petal length, and fourth one is petal width. So that you can simply rename here. Right, you can simply rename here. Basically data dot column, uh, in a square bracket I have written the whole name. You can simply type sepal length as SL, whatever name you want to type it. And after that I have printed the data dot head so that I can see the info, and I can get the column has been renamed as sepal length, sepal width, petal width, right? And the fifth one as species. After that I want to note the fifth column that I have tried to know the feature, the different types in the species, right? That's why I have taken as the data species dot unique. Basically, it will represent the different unique types, and that is the species has. Basically, it has the three types: Iris setosa, Iris versicolor, and Iris virginica, right? That it has basically three types of data type, right? After that I have tried to know that is there any null entries in our data set. For that I have used the data dot is null dot sum so that it can represent the then so that it can represent any of the null entries there in our data set. As you can see here, the sepal length has 0, and the sepal width has 0, petal length has 0, and petal width has 0, and even the species has 0, right? Now we can know that there is no null entries in our data set, and we are ready to go further, right? After that I have taken x uh, basically attributes as data dot ilog. Basically ilog function is basically used to uh, access using indexing, right? And log function is basically to access using its value. Basically I have used ilog function to access using indexing, and so that this is basically 0 1 2 3, and basically I have marked it the column as 0 1 2 3 because as you can see here even the indexing start from 0. That's why you can take it the 0 as sepal length, 1 as sepal width, 2 as petal length, and 3 as petal width, right? These are basically the feature of the dataset, or you can even say the attributes, right? After that I have used the using elbow method to determine the optimum number of cluster for k-means, right? For that I have imported the k-means from sklearn.cluster. This is basically this is a clustering algorithm that I have to apply over the iris dataset. That's why I have imported the k-means. wc WCSS, basically this is nothing. I have named it as array, right? For I in range, basically I have taken it from the 10 number of iteration, number of clustering I in it came in the number of maximum iteration that will happen, that is 300 in it for the range of 10, and the random state I have taken that is 0. After that I have fit the model k-means dot fit x and wcs dot append k-means dot inertia. After that I have tried to plot the graph. Basically, I have used the plt.plot range 1 to 11 WCS, and WCS is basically nothing that is within the cluster sum of squares, right? And for that, I have named the data as elbow method, and x level as number of cluster, and y level as WCSS. We have plotted the graph. As you can see here, there is three edges. The first one is here, the second one is here, and third one is slightly here, as you can observe from here. Right. After that I have implemented the k-means clusterings. There is basically a number of cluster will happen three. Basically it has the three types: iris artosa, iris virginica, and iris versicolor, right? For that there is a three. And I have used maximum iteration 300, and random state is 0. Basically we take the fixed number of a fixed random state. Either you can take whatever you want, either you can take 1 250, whatever you want. Basically if you fix a random state, then whenever you predict the accuracy of a model, or or the value whatever you want to predict, it will give you fixed value. Otherwise, if you remove the random state from here, right, you will get different values at different predictions, right. To state a consistency in your accuracy or models, that's why you have to use the random state. After that, why k-means dot fit, we have fit our model. After that, we have tried to visualize the model using a scatter plot, right. For that, we have used the label iris autosa and given it a color of purple, right. And iris versicolor, that I have given the color of orange, and iris virginica, that I have given the color of green.